All right, today we're going to look at section 10.5, and we're going to look at the different angles that can be formed with secants and tangents, and actually we should add chords to that, okay? The first example that they show you is when you have a circle and you have either a chord or, in this case, this line is a secant, okay? You got a line that's going through the circle, it's touching the circle twice, so if I extended that line going this way, that would be a secant. And then this would be a tangent line. Okay, this tangent, if I extend it going this way, that's only touching the circle in one spot. If we extend this line, okay, it's touching the circle in two spots. So we have the combination of a secant and a tangent, and they are intersecting on the circle. So just like the inscribed circle that we talked about, we just finished section 10.4, where when we have that vertex that's on the circle, okay, whatever this angle measure is, if this was 20, then we know that the arc would be 40. Okay, we said that with the inscribed angle. Well, the same thing applies. Okay, we've got a vertex on the circle. Okay, so I can take that arc, which is 140 degrees. The angle measure is going to be half of that, just like it was with the inscribed angle. Because this is still an inscribed angle. It's still the vertex is on the circle, so that same rule applies. Okay. Another scenario you might see, if I have two chords, or they could be secants. So chords, we know have endpoints on the circle. There's one chord. If it intersects another chord, now does that look like it intersected at the center of the circle? No, it's not the center. So it doesn't matter where it intersects, but when it intersects out here, what we say is we take the intersected arcs. Okay, so the arc out here on this intersection is 48 degrees, and the arc over here is 76. We're going to average those. Okay, so if I add them together and divide by 2, I'm going to get the measure of this angle. And if this angle is 62, then these are vertical to each other. They're both going to be 62. So when the point of intersection is inside the circle, so those two chords are intersecting each other inside the circle, we're going to take and we're going to add the arcs and divide by 2. We're going to average them. So you add the arcs divided by 2. Versus, okay, here's a couple of, okay, these would have to be secants in order to intersect outside the circle, but here we have a secant. It's going through the circle, and here's another secant. And where are they intersecting each other? Well, they're intersecting each other outside the circle. Since that point of intersection is outside, instead of adding the two arcs, we're going to subtract the two arcs. So we're going to take 76 and we're going to subtract 28. We always take the larger arc and subtract the smaller arc and divide it by 2. So this angle outside of the circle is 24 degrees. So if the point of intersection is inside the circle, we're going to add the two arcs and divide by 2. If the point of intersection is outside the circle, then we're going to subtract the two arcs and divide by 2. So you really need to look and to see where that point of intersection is. Okay, and here's one last picture. Okay, if I look at where these lines are, these aren't secants now, but these are tangents. Same rule applies. These tangents, where are they intersecting? Oh, they're intersecting on the outside of the circle. And because it's outside, we're going to subtract the 2. We're going to take 244 and we're going to subtract 116. And then divide my answer by 2. So you can see the math up here. 244 minus 116 divided by 2. That angle outside the circle is 64 degrees. Okay, and then here's a summary. The question you got to ask yourself is, where is the vertex of the angle? Okay, if it's exactly on the circle, so that vertex, if you go up a few diagrams where I started, if the vertex is on the circle, you just divide the arc measure by 2. So that might be a picture where I have this going on. Here's the vertex on the circle itself. If the vertex or the intersection point is inside the circle, that's when we add the arcs and divide by 2. And if it's outside the circle, here's that vertex, that intersection point is outside the circle, that's when we subtract the arcs, and we divide by 2. Okay, so now you can go ahead and you can focus on that 10.5a worksheet.